Things had not been going well for the small 11-year-old boy at King's School in Grantham, England. Isaac Newton was a poor student, and his test scores put him next to the bottom of the class. His mind wandered, and he liked to stare out of the window and think about the experiments and projects he could do at home. Today, he had an idea for a windless windmill. He would power it by a mouse on a treadmill. But of course there would have to be something to motivate the mouse. Oats, maybe. If he put some oats at the top of the treadmill, just out of reach. This experiment, at least, wouldn't upset his neighbors, not the way the kite had. A few weeks earlier, he had tied a lantern to the top of a kite and set it adrift, just to watch the glow of the light in the evening sky. The neighbors had panicked. They thought it might be a comet, and everyone knows comets foretell disasters. From now on, he would try to do his little projects at home, where no one else could see them. The children at school found Isaac strange, quiet, unsociable. As he walked to school that morning, a boy academically above him in class had run up, insulted him, and kicked him in the stomach. Isaac had responded by challenging him to a fight after school, a fight which he had won. But somehow it didn't seem enough. Now, as he trudged home, dirty and bruised from the tussle in the schoolyard, he wondered what else he could do to avenge himself. He'd won the fight, but his young enemy could still feel superior as long as he was above Isaac in the class ratings. So there was only one choice. Isaac would have to beat him academically as well. From then on, he vowed to concentrate on his studies, and within only weeks he had passed not just his young adversary, but every other child in class. The year was 1653, and the incident at King's Grammar School was typical of a pattern that would repeat itself many times in the life of Isaac Newton. He was one of the most creative geniuses the world had ever seen, and to many people the greatest scientist who ever lived. Yet his life was plagued by angry conflicts and bitter feuds with colleagues and rivals. These feuds sometimes caused him mental breakdowns, and other times triggered great bursts of work that led to brilliant new achievements. On January 8, 1642, the remarkable scientist and astronomer Galileo died. At the end of the same year, on Christmas Day, Isaac Newton was born. Galileo brought scientific thought to the brink of a new age. Newton would take it the rest of the way. When Newton was born, not only could few have guessed about his eminent future, but few could have guessed he had any future at all. He was born prematurely and was so frail he wasn't expected to survive the day. His mother later said he was tiny enough to fit into a quart mug. Newton's life was marked with adversity from the start. His young father died months before he was born. His mother, Hannah Newton, remarried 2 years later and simply left Newton behind with his grandmother. Although she lived only a mile away, she seldom saw Isaac and soon became preoccupied with 3 new children from her second marriage. Now, psychologists like to play around with the idea that Newton suffered feelings of parental rejection, and this is why he exhibited personality extremes later on in life. They also like to blame his mother for the fact that he never married, and in fact never even had a romantic relationship. The character of Isaac Newton was far too complicated to reduce to a pat psychological formula, but there's no doubt he felt a great deal of bitterness towards his mother and stepfather. When he was 20, he wrote a catalogue of his sins in which he included threatening my father and mother to burn them and the house over them. On his grandmother's farm in the small village of Woolsthorpe, little Isaac Newton kept himself very busy. At school he studied mostly Latin, but at home he studied everything. He particularly liked to build gadgets, water clocks, sundials, water wheels, and of course, windmills and kites. When he started school in nearby Grantham, he stayed with friends of his mother, who were druggists. He liked nothing better than to watch the work in the apothecary, and it's here he first developed his interest in chemistry. When he was a teenager, Newton's mother returned home to Woolsthorpe because her second husband had died. She took Isaac out of school so he could help run the farm, believing that since he was good with his hands and had a quick mind, he would be a very capable manager. But because he was indeed quick with his mind, Isaac was an absolutely terrible manager. When he was supposed to be watching the sheep or cows, Isaac was curled up under a shady hedge with a book. When he was supposed to be taking the produce to market, he was down in the fields, jumping this way and that, trying to determine by the lengths of his jumps what the force of the wind was. When he should have been feeding the chickens, he was jotting down thoughts in his notebook. At the front of the notebook he'd proudly written, Isaac Newton owns this book. It included, among other things, his formula for making chalk, recipes for purging the head and making the brain clear, a phonetic alphabet, methods for making gold ink, magic tricks, and astronomical observations. And while he wrote all these ideas, the cattle were wandering onto the neighbor's land, and the hens were still waiting for their eggs to be collected. One day he was sent to Grantham on business, a chore he always liked, because he could drop in on his old friend the druggist and spend the afternoon ogling the chemical bottles. On his way home from town, he dismounted his horse so it could have a rest, and walked along leading it by its bridle. As always, his mind wandered. Perhaps he was thinking about the four-wheel carriage he just built, or the system of shorthand he'd created, or maybe he was just watching the sunlight on the grass and wondering what made the grass green. Whatever, miles and hours later, he arrived at home, not even aware that the horse had long ago slipped out of its bridle, and he had walked the whole way back alone. This absent-mindedness, typical of so many great scientists and thinkers, stayed with Newton his whole life. One of the most famous stories about Newton was told by a friend who had an appointment to join the scientist for dinner one night in his room. He arrived and found Newton deep in thought, so he decided to sit down and wait. Newton continued to think and to make notes on the paper before him. Time passed. A servant came in with dinner and set it before Newton. More time passed. Finally, the friend decided to eat the dinner himself. Shortly after, Newton looked up, startled to see his friend there. Then he saw the empty plate. He said, "If it weren't for the proof before my eyes, I could have sworn that I have not yet dined." In later years, after he had attained wide fame for his many achievements, an admirer asked him how he had managed to come up with so many brilliant discoveries. He responded simply by always thinking about them. But when he was a teenager, this constant thinking in place of chores drove his mother almost frantic. Finally, it became clear to her Isaac Newton was not meant for a farm. He was meant for a college. She sent him off to Cambridge, where he was admitted as a subsizer, a student who earned his way by working part-time as a servant to other, wealthier students. His first years at Cambridge were quiet and unremarkable. By the time Newton entered college, the scientific revolution of the 17th century was well underway. Men like Copernicus, Kepler, Galileo, and Descartes had all helped develop a new view of nature. This new nature was impersonal, intricate, and operated under specific rules and mathematical principles. Yet at Cambridge, everyone was still studying the old science, the science developed by the ancient Greeks 2,000 years before. Newton studied it too, but in his notebook he'd written, "Amicus Plato, amicus Aristotle, magis amica veritas." Plato is my friend, Aristotle is my friend, but my best friend is truth. Newton kept to himself and studied, avoided parties, and conducted experiments in his room. In one experiment, he almost ruined his eyes by watching the sun for hours at a time to observe its colors. He had to spend several days in complete darkness before his eyes regained their normal vision. Newton earned his degree in 3.5 years, and then made plans to stay on and pursue his studies. But those plans were interrupted. They were interrupted by an unwelcome visitor, who affected not just Newton's life, but lives all over England, the plague. The Great Plague began in London in 1664 when Newton was 22 years old. By the summer of 1665, it had spread close enough to Cambridge to cause panic in the outlying districts. The university was quickly closed, and Newton returned home to Woolsthorpe, where he spent 2 years waiting for the plague to run its course. Those 2 years, from 1665 to 1667, are among the most famous years in the history of science, for it was there in Woolsthorpe that Isaac Newton developed his most important work so remarkable that the period he spent in Woolsthorpe is called the miraculous years. Newton used his time on the farm to assimilate all he'd so quietly learned and thought about at Cambridge. Although he was only 23 when those years started, by the time they were over, he had come up with the 3 ideas that would make him famous: the origin of color, the nature of gravity, and the invention of calculus. Any one of those ideas alone would have changed history, but for the moment, Newton kept all 3 to himself. When the plague finally ended with the help of the Great Fire of London in 1666, Newton returned to the university where he quickly earned a master's degree, then a fellowship. Then the mathematics professor at Cambridge, aware of the unique brilliance of his student, actually resigned his position so Newton could assume the post. The professor went on to pursue a new interest, religion, and at the age of only 26, Newton took his place. Newton's lectures as a professor were not exactly a success. Few attended, and fewer still could understand what he was saying. He often made his entrance only to find the lecture room empty. What these students were missing was Newton's revolutionary new theories about light, color, and optics. Later he would publish these in a book that brought him his first national fame. For now, he spent his time studying and pursuing his own thoughts and experiments. Friends at the time said he did nothing but work. He was never known to take any recreation, any walks, or exercise, and he had no pastimes or hobbies. He ate sporadically, and even then he'd take his meals standing up. He rarely joined the others for meals in the dining room, and when he did, he seemed to forget where he was going. More than once he was seen to walk in, turn left, and go out into the street, stop, realize his mistake, and re-enter, then head not for the dining room, but back to his dormitory. Newton rarely went to bed before 2 or 3 a.m., and even then he slept only 4 or 5 hours. During his most intensive work, he disciplined himself to be in bed by midnight. He found that if he stayed up even a little later, it damaged his health and hurt his work. His clothes were often untidy, and his friends and students were often amused by his worn-out shoes, his untied stockings, and uncombed hair. Someone who knew him for many years said in all that time he'd only seen Newton laugh once. Newton's experiments with optics during this time led him to build the world's first reflecting telescope, which immediately caught the eye of the Royal Society of London, the leading scientific society of Europe. The society asked to see the telescope, and Newton gladly sent one, along with detailed descriptions of his work and conclusions about the nature of light. It was here that one of his first feuds would begin. One of Newton's views about light was that it was made up of small particles of differing sizes. The largest particles were in red light, which is the most difficult to deflect, and the smallest were in the violet light, which is the easiest to deflect. This view was in direct conflict with an eminent scientist and member of the Royal Society named Robert Hooke, who considered himself the world's leading expert on optics. Hooke believed light was more like sound, made up of waves. Furthermore, he rejected Newton's idea that light was made up of a spectrum of colors, even though Newton's experiments had pretty much proved this theory. He wrote a critique of Newton's theories that sent the young scientist into a violent rage. The argument soon escalated and went public. Newton at this time was growing impatient with having to defend his ideas. He complained of the many letters he had to respond to from all over Europe, everyone asking him to explain this and answer that, when all they had to do was conduct their own experiments and find out for themselves. The battle with Hooke continued for many years, with Hooke eventually trying for a reconciliation. He wrote an apologetic letter that suggested they were both just seeking the truth, but which also damaged Newton's ego by praising him for contributing to the work Hooke had already begun. Newton wrote back an equally annoying letter that said, "If I have seen farther, it is by standing on the shoulders of giants." The suggestion that he was seeing farther than Hooke didn't sit well. As time passed, Newton became more and more sensitive to criticism. He was not yet 30 when he submitted his ideas to the Royal Society, and only a few years later he retreated into a shell, working alone, keeping his ideas to himself, and refusing to publish his findings. He didn't publish his complete findings on light until he was 61, and Hooke had died. The book was called Optics, and for many years later, its theory on light particles was the theory most leading scientists accepted. Today we can say that both Hooke and Newton were right. Light does behave something like a wave, and it does have particles called photons, but it can't be described simply by either term. After he submitted his telescope to the Royal Society, Newton was elected a Fellow of the Society. By then the year was 1672, and Newton was 30. Over the next few years, he continued to publish papers on light and optics, continued to receive criticism from Hooke, and continued to lash back both privately and publicly. He also launched an angry campaign against some English Jesuits in France, who had made some mild objections to his theory on colors. He shot off a series of furious ranting letters, and then, in 1678, at the age of only 36, he suffered a complete nervous breakdown. With the death of his mother the following year, he went into seclusion, where he remained for 6 years. In those isolated years, when he communicated with almost no one, Newton developed an interest in alchemy and pursued his ideas about motion and gravity. When he finally emerged, it was to release the most astounding book in the history of science. Newton's masterpiece, the book believed by many to be the greatest example of scientific genius ever, was called Principia. He released it in 1684 when he was 42 years old. Principia was a detailed explanation of the laws of gravity and motion, particularly as they applied to astronomy. When it was published, Newton instantly became the leading scientist of his age. It was the last great work he would produce. When Newton sent a copy of a part of his Principia work to the Royal Society, Robert Hooke accused him of plagiarism, and the old feud was fired up once again. Hooke, who was old and quite ill by this time, was incorrect in his charge. Most believe he simply wanted some credit for some of his ideas in the same field. Instead, Newton went through his manuscript and scratched out every single reference to Hooke, then refused to publish any more works with the Society until Hooke was dead. In 1693, at the age of 51, Newton suffered another nervous breakdown. He began to send angry letters to his personal friends, including the writer Samuel Pepys and the philosopher John Locke, accusing them of things that were completely imaginary. In the case of Locke, Newton charged him with trying to entangle him with women. Both friends became alarmed and feared Newton was going insane, but shortly after he seemed to recover again. He retired from research and moved to London. 3 years later, when he was 54, the government offered him a prestigious position as Warden of the Royal Mint, and a short time later, Master of the Royal Mint. It was a high-paying position, and one in which his concerned government thought he might be able to relax and rest a bit. But Isaac Newton didn't know how to relax. He immediately launched a relentless campaign against counterfeiters, sending many of them to the gallows. He was so ferocious in his duty that some people thought it had become a channel for all the anger he'd stored up over so many years. During Newton's days, it was common for mathematicians to have contests, and Newton was impossible to beat in these. When he was 54, a famous mathematician announced 2 complex problems and challenged masters all over Europe to solve them within 6 months. At the end of that time, the problems had not been solved, but he was asked for an extension of the deadline. These problems, the contestant said, were unusually difficult. They were given the extension. One night, Newton returned from a long day working at the Mint and found a magazine had been delivered that had a copy of the problems. He began to work on them at once, 8 months behind everyone else. The next morning, he took his solutions to the president of the Royal Society. They were published anonymously, but the creator of the problem said he immediately recognized the author, in his words, as the lion is known from a claw. When he was 61, the Royal Society elected Newton president. They had offered him the post earlier, but he refused to accept it until Society member and foe Robert Hooke had died. In his later years, Newton did most of his work at home in the study above his bedroom. It was lined with 6 bookcases, containing over 1,800 books. Every single one had his bookplate, Philosophimer, Let Us Seek Knowledge. In addition, there were thousands of pamphlets, a walnut writing desk, a table, library chairs, 210 prints, and Irish lace tapestries. His friend said he was never for one moment without a book or pen in his hand. He worked on his new passion, religious studies, for hours daily, concentrating partly on a chronological table of the events in the Bible. He remained president of the Royal Society until his death, but in his later years developed yet another feud, this time with the astronomer royal John Flamsteed. He tried to force Flamsteed to publish his catalogue of stars, even though Flamsteed felt he needed more time to finish it. The saga that followed lasted 10 years. Newton used government connections and had Flamsteed's work seized and prepared for publication. Flamsteed took the case to court. The papers were returned, and Flamsteed burned them all. And finally, Newton, out of revenge, removed every reference he'd made to Flamsteed in Principia, for which Flamsteed had supplied much supportive material. As if this soap opera weren't enough, Newton was meanwhile battling it out with a German mathematician named Gottfried Leibniz. The two accused each other of plagiarism in their work on calculus, and Newton stooped to all kinds of questionable antics, including writing articles in his own defense and signing them with other people's names. He also assigned a supposedly impartial committee to investigate the matter, then secretly wrote the committee's report himself. Even after Leibniz had died, almost any paper Newton wrote contained at least one paragraph that was a furious attack on him. Years after Newton's death, it was proposed that much of his erratic behavior might have been caused by mercury poisoning. He used a great deal of mercury in his experiments in alchemy, and at the time, no one recognized the dangers. Recent studies of a hair sample from Newton showed he had 40 times the level of mercury considered normal. When he was 63, Queen Anne bestowed knighthood on Newton, and he became Sir Isaac Newton, the very first scientist to be so honored. As he entered his 80s, Newton's health began to fail, and he moved to the London suburb of Kensington, where the air was cleaner. In March of 1727, he presided over his last meeting of the Royal Society, and 2 days later he became seriously ill. The man who, as a baby, was not expected to live 24 hours, was 84 when he died. He was buried at Westminster Abbey, where the inscription on his tomb reads, "Let mortals rejoice that there has existed such and so great an ornament of the human race." Shortly before he died, Newton had said, "I have been but as a child playing on the seashore, now finding some prettier pebble or more beautiful shell than my companions, while the unbounded ocean of truth lay undiscovered before me." Those pretty pebbles and shells are still among the greatest contributions ever made to the field of science. Let's examine them in a little more detail. The 3 greatest discoveries of Isaac Newton were all made during the 2-year period when he was at his family farm in Woolsthorpe while he waited out the plague. The first was his theory of color, or optics, a theory so advanced that years later Albert Einstein would say of Newton, "Nature to him was an open book whose letters he could read without effort." Before Newton, scientists still believed Aristotle's ancient theory that white light is a simple pure entity, with no parts or multiple qualities. Newton proved differently. His work with color began with experiments with prisms. At the time, scientists believed that a prism changed the rays of the sun as it passed through, thereby creating the variety of colors that spilled out. They thought light started out white and was darkened by the prism to shade the blue, green, violet, and the rest. Newton had a different idea. He believed the prism didn't change the light, it only reflected what was there to start with. Sunlight was already a blend of different colors, and each emerged as they were bent differently through the prism. He conducted different experiments that proved his point, and then identified the various colors of light: red, orange, yellow, green, blue, indigo, and violet. Today, indigo and violet are considered as one, violet, but Newton separated them because he liked the idea of having 7 colors to match the notes of the musical scale. He called this array of colors the spectrum, which is what they've been called ever since. With Isaac Newton, as with most scientists, one discovery always led to another. In this case, his work with prisms and lights led him to invent a new telescope. As he studied light, he realized that telescopes of his time were defective. If they focused on one ray of light passing through the lens, say a violet ray, other rays would be out of focus, such as the orange rays. The solution, he decided, was to build a telescope that focused with a mirror instead of a lens. In a mirror, all colors are reflected the same and would focus together. With that inspiration, Newton built the first reflecting telescope. The second major discovery Newton made at the farm was calculus. At the time, he called it his method of fluxions. He came up with simple analytical methods that brought together a whole range of different techniques that had been developed to solve problems such as finding areas, tangents, and the lengths of curves. Those methods became a powerful tool of problem-solving in both mathematics and physics. The third revolutionary discovery Newton made in the farm years is the one he's perhaps most famous for, the theory of gravity. This is the discovery that involves the legendary story about an apple falling from a tree. The story goes this way. One day Newton was sitting under a tree in his orchard wondering about the forces that keep the moon in orbit. At that moment, an apple fell and landed with a plop beside him. It triggered an idea. Could it be that the force that pulled the apple to Earth might be the same kind of force that holds the moon in orbit around the Earth? This idea led him eventually to the law of gravitation and its application to the motion of heavenly bodies. It's a delightful story, but is it true? That depends on whom you choose to believe. The writer Voltaire was among the first to tell this story, and he said he heard it directly from Newton's niece. There were others of the time who say they heard it directly from Newton. Still, many scholars and historians refuse to accept the story as fact. Undoubtedly, if it isn't fact, it's close to fact. There's no doubt that Newton originated his law of gravity while staying at the farm, where he liked to do almost all of his thinking out of doors. It's also true he was the type of creative genius who often took his inspiration from observation of nature and the events around him that seemed so ordinary to others. But however it occurred, his discovery of gravity was one of the greatest achievements in science. With that discovery, he described the three laws of motion. The first is the law of inertia. If a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it's acted upon by a force. The second law is the law of force. It's a description of the changes a force can create in the motion of a body. It states that the speed or acceleration of a body is directly proportional to the force and inversely proportional to the mass. The larger the force, the larger the acceleration. The larger the mass, the smaller the acceleration. This is his most important law. It is the one that leads to all other basic equations of dynamics and has served as the framework for natural science ever since. The third law is that the actions of two bodies upon each other are always equal and directly opposite, or more commonly put, to every action there is an equal and opposite reaction. It means simply that the downward force of a book slammed onto a table is equal to the upward force of the table on the book. It was Newton who originated the term gravity, using the Latin word gravitas, which means heaviness or weight. He also discovered at this time centrifugal force, the force away from the center of a body moving in a uniformly circular path. The tremendous insight that came with all his work on gravity was Newton's idea that the Earth's gravity extended all the way to the moon, offering a counterbalance to its centrifugal force. He was able to figure out that the centrifugal force of the moon, or any planet, decreases as the inverse square of its distance from the center of its motion. Put in simple terms, that means that if the distance of the moon is doubled, the force becomes 1/4 what it was. If the distance is tripled, the force becomes 1/9 of what it was. In 1684, at the age of 44, Newton took all these findings and published what's considered his greatest work. It might never have been published at all, except for the urging of his friend Edmond Halley, a young astronomer we know today as the discoverer of Halley's comet. Halley was irritated by some of the boasting of Newton's old nemesis, Robert Hooke. He knew that some of the theories Hooke was taking credit for had been proven 5 years earlier by his friend Newton, but Newton had mislaid his papers on the subject. Halley pleaded with him to find them, and Newton finally located the proofs and expanded them into a paper on the laws of motion and problems of orbital mechanics. In other words, how and why the planets, moons, and other heavenly bodies move as they do. Newton worked 18 months on his paper until he transformed it into a full-length, brilliant treatment of new physics and their application to astronomy. It was called The Mathematical Principles of Natural Philosophy, or, as it's known today, Principia. Almost all experts agree that Principia is the greatest scientific book ever written. It is the fundamental work for all of modern science. In Principia, Newton fully analyzed the motion of orbiting bodies, projectiles, pendula, and free fall near the Earth. He demonstrated that planets were attracted to the sun, and that all heavenly bodies mutually attract one another. He expanded his law of universal gravitation, that all matter attracts every other piece of matter with a force proportional to their masses and inversely proportional to the square of the distance between them. With his laws of gravitation and his laws of motion, Newton was able to explain all kinds of things people had never understood before, including the unusual orbit of comets and the causes of the tides. Now all the work that had preceded him, that of Copernicus, Galileo, and Kepler, was unified into one sound scientific theory. Sir Isaac Newton was the culmination of the scientific revolution of the 17th century. His work became a major turning point in the history of scientific knowledge. It did that simply by bringing order to chaos. Newton extracted the facts from great masses of theories, some of which were completely absurd. Then he took those different facts and those varied theories, and he put them into an ordered whole. He was the integrator, the unifier, the organizer of all the scientific knowledge available at the time. In doing so, he established the solid platform on which all modern science could build. Alexander Pope, the leading poet of Newton's age, had written, "Nature and nature's law lay hid in night. God said, 'Let Newton be,' and all was light." From this rare man, whose own emotions and thoughts seem so often to be in chaos and darkness, came the great ironic gift of order and light.